Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 1 in Advanced Math Topics. This chapter is kind of a review of kind of foundational algebra skills. And so for 1.6 here, which is this section, we're going to be talking about properties of exponents. Our essential question is, how do we use properties of exponents to simplify expressions? And so for the warm-up here, we're just kind of reviewing simplifying fractions. Why don't you guys go ahead and see how you do with this. Go ahead. All right, so for simplified fractions here, we need to, how do we simplify fractions? Well, to simplify them, we need to find a greatest common factor on top and bottom. So, a number that goes into 14 and 20, the biggest number is going to be 2, so we divide by 2 on top and bottom. And 14 divided by 2, we got the negative in front, it's going to be negative 7. Over, what's 20 divided by 2? It's going to be 10. All right, nice. All right, how about number 2? We're multiplying. So it's multiplying fractions, no big problem. Top times top over bottom times bottom. When we're multiplying, though, we can do some reducing or canceling. So we can reduce vertically or diagonally. So what can we reduce here? Well, let's use different colors here. I want to do the 18 and 6. I can go diagonal or vertical. I'm going to go diagonal here. What number goes into 6 and 18 nicely? 6, right? So 6 goes into 6 once, 6 goes into 18 3 times. All right. How about the 12 and 10? Remember that goes into 12 and 10? Yeah, they're both even. So 2 goes into 12 6 times, 2 goes into 10 5 times. Now we can rewrite this. So we have 6 over 3 times 1 over 5. Okay, can we do any more canceling diagonally? No. How about vertically? Yeah. What number goes into 6 and 3? 3 goes into 3 once, 3 goes into 6 twice. So now what we have is 2 over 1 times 1 over 5. And now we're reduced as far as we can. Now we can just multiply straight across. So 2 times 1 is going to be 2. And we have 1 times 5 is going to be 5. So you could multiply straight across there to 12 times 6 and 18 times 10. But then you're going to have to reduce like a really big number. What's that? 72 divided by 180, which is going to require some reducing anyway. So nothing wrong with that, but it gets a little bit messy. So, all right, number 13. Dividing fractions easy as pie. Flip the second and multiply. Or we do what's called keep, change, flip. Okay? So if you want to pause it and see if you can try this now, give it a try. Yeah, so we're going to flip this. We're going to do keep the 12 over 18. We're going to change division to multiplication. We're going to flip 6 over 10 to 10 over 6. All right, number 3 is just like the last one here. If you want to see if you can do some reduce, cross or vertical reducing, give it a try first. All right, let's do some reducing here. So I see 12 and 6 is kind of nice. I'm going to reduce 6 goes into 6 once, 6 goes into 12 twice. How about 18 and 10? 2 goes into 18 9 times. Let's write that a little bit nicer though. And we got 2 goes into 10 5 times. So now we have 2 over 9 times, then we have 5 over 1. All right, any other canceling we can do here? No, we can multiply straight across, so 2 times 5 is going to be 10, 9 times 1 is going to be 9. And we like improper fractions, we don't want to do mixed numbers anymore. Okay, let's get into properties of exponents now. So what's an exponent, or what's powers? Why don't you guys see if you can label this diagram here. We have 2 to the third here. See if you can label what's the exponent, what's the base, what's the power, okay? Give it a try. All right, so the whole thing, what's the whole thing called? Is it exponent, base, or power? I guess if you want to pause it again, that was kind of eluding you. One of these things is like the whole thing. What do you guys think? It's the power. The whole thing is the power. What's the little number called? The little number is going to be called the exponent, and the big number is going to be called the base. Okay, what's down here is the power. The whole thing is the power, all right? All right, so moving along here. So we're going to talk about the properties of exponents, right? So 2 to the third, what it's saying is basically like how many times we multiply that together. So this would be equal to, it's not 2 times 3, it's 2 times 2 times 2. It's 3 2s, right? So keep that in mind. That's what we're talking about here. We're talking more variable stuff, but it's basically the same thing. This is 2 times 3 is repeated multiplication. That's 2 plus 2 plus 2. And repeated exponents are repeated multiplication, which is 2 times 2 times 2. Okay? Alrighty. So we have some different kinds of things here, some different properties. Why don't you pause the video and see if you can figure out what the properties are. So it says when we multiply powers with the same base, we blank the exponents. Why don't you guys fill out this whole page here? See if you can figure them out, and we'll go through them in a second. All right, so the trick with this, if we do x squared times x to the third, that's going to equal x to the fifth. Well, how do we get 5 from 2 and 3? We're going to do x to the 2 plus 3, which is going to be, we're going to add the exponents. Okay, so when you multiply, you add the exponents. Good job if you got that one. So when we multiply, we add. What we do when we do a power to a power, this is pow-pow. So we're taking a power to a power. This is basically, if I give you a hint here, if you need one, we have 2y to the thirds, right? So if we do the same thing as we did before, we multiply y to the third, it's going to be y to the 6. How do we get 6 from 3 and 2? Well, we multiply. It's going to be y to the 3 times 2. So we're going to multiply the exponents. All right. How about something taken to a power of 1? If you guys want to use a calculator here and check it, like 5 to the first power, 1,000 to the first power, pi to the first power. What do you guys think? Well, 5 to the first power is going to be 5. 1,000 to the first power is going to be 1,000. Pi to the first power is going to be pi. So what is it equal to? It's equal to itself. Okay. All right, last one's a little tricky. What are things taken to the 0 power? You may want to use a calculator for this too, but 7 to the 0 power is going to be what? It's going to be 1. Same thing for 25 to the 0 power is 1. And be careful, this is kind of like complicated here, this big thing right here. But this whole thing, because it's the 0 power, it's going to equal 1. You don't need to actually solve anything. So anything to the 0 power is going to equal 1. Nice. All right, we have some examples of each of these here. Why don't you guys go ahead, now we've done through a few examples here, so you can figure these out, and we'll go through them in a second. All right, it also says here, be careful when you're using like numbers, numerical powers, make sure that you simplify. So you don't want to leave 2 to the third, you want to write 8, because it's 2 times 2 times 2, okay? So we have 5 to the second times 5 to the third, that's going to be 5 to the what? Is it going to be 5 to the 6th or to the 5th? It's going to be 5 to the 5th. We do 2 plus 3, okay, which is 5 to the 5th. And if you plug in 5 to the 5th in your calculator, you're going to do like a button looks like this on your calculator if you need to know that. Okay, it's like to the power, so you would do 5, power, 5, and then hit equal. So that's the buttons you would press on your calculator, okay? It's going to be 3,125. Nice. All right, how about v to the 4th times v to the 7th? It's going to be v to the 11th. Very cool. How about number 3? Ooh, it's kind of weird. We've got a negative here, but it's the same thing. We're doing negative 5. We're multiplying, so we're still going to add plus 9. That's still going to work out nicely. What's negative 5 plus 9? It's t to the 4th. So even though we may have freaked out a little bit, it didn't really matter, okay? All right. If you guys want to try the power to a power, now we've gone through with some of these, give it a try. All right, so 3 to the 4th all to the 2nd is going to be 3 to the 8th. Okay, 4 times 2. We're not quite done, though. We got to plug 3 to the 8th in our calculator, which is going to be 6,561. All right, number 2. Is it 3 plus 7 or 3 times 7? 3 times 7. We got m to the 21st power, 3 times 7. Nice. How about number 3? We have negative 5 times negative 3 is going to be p to the 15th. Positive 15. And there we go. All right, back to exponents of 1 and 0. All right, so down here, 19 to the 1st power, is that 1 or 19? It's 19. This is really kind of big there. It's 19. It's equal to itself. How about 40 to the 0 power? I think the 0 is going to be 1. How about 30,000 to the 1st power? It's actually going to be 30,000. If you put 1, I tricked you. I did that on purpose to kind of trick you, but yeah, it's the 1st power. It's going to be itself. All right, very cool. We got some steps for, I guess, simplifying exponential expressions. So these are general rules that I follow, but it's not always applicable. Sometimes I like to simplify inside the parentheses, but in general. So the steps are, we do pow-pow, we multiply straight across, we do negative and 0 exponents, and then we reduce fractions and cancel exponents, okay? And it says down here, it may be a good idea to switch it up depending on the problem, all right? So let's try a couple. So why don't we do... Let's do number 2 and number 4, okay? And you guys will try the other 2 on your own. So number 2 and number 4. Let's do number 2 first, okay? So we have yx squared times 4x to the third times 2x squared y to the second. So do we have any pow happening here? Any parentheses anywhere to do? No. So now we're going to multiply straight across. We're going to combine things, okay? I'm going to break this down a little bit here, okay? So I'm going to multiply all the big numbers first, all the big bases here. What number's in front of the yx squared? It's actually a 1 here. So I'm going to multiply out, we got 1 times 4. So just to kind of show what's happening here, we're going to kind of rearrange things and multiply them, the things that go together here. Okay, we're going to multiply 1, 4, and 2, right? These are kind of like bases. We have x's, right? So we have x. What x's do we have? We got 2, 3, and 2, right? So I'm going to do 2. And if we're multiplying, are we going to add or multiply? We're going to add. So 3 plus 2 plus 3 plus 2. And then we have y. We got this is the first power. There's nothing there. It's to the first power. And we got y to the second power. So it's going to be 1 plus 2. Okay, and now we can kind of, it's not really like, just kind of showing you what's happening here, okay? So 1 times 4 times 2 is going to be 8. And then we have x to the, we have 2 plus 3 plus 2 is going to be 7. And y to the third. Okay, so I'm kind of breaking it down there. If it's this way it's a little complicated for you. As long as you kind of show your work, and I would really try to show some work, like where things are going, because there's a lot to look at here, okay? Why don't you guys go ahead and try number 1 now that we did this one, see how you do. All right, number 1, we have this one right here. We have x squared y to the fourth times 4 x to the 0 y to the second. So we're going to multiply what we have here. So in the front we have a 1, so we got 1 times 4. We have x, we have to the second power and the 0 power, so 2 plus 0. And y to the, we have 4 plus 2. Okay, kind of breaks it down nicely so we know what we have. 1 times 4 is going to be 4. We have x, 2 plus 0 is 2. And 4 plus 2 is going to be 6. So we have 4x to the second, y to the 6. All right, sounds good. Cool, let's do number 4 now. This is kind of what I was talking about. So you could do pow and do the 4 to everything in the parentheses here. I probably would, you could do that, that's fine. But with this one, it's kind of clumsy, but I would probably combine stuff inside the parentheses first and then kind of do pow to it, okay? So that steps were kind of a general thing here, but I would always simplify it inside the parentheses if you can. Not always, but if there's a lot of the same base moving around, we got x and x here and y, I combine them before I do stuff, okay? So inside the parentheses, we have x to the first. So we got 1 plus 3, right? We got x to the first, x to the third. We have y to the 1 plus 2. This is all to the fourth, okay? Now, so that's going to give us what? In the parentheses, now we have 1 plus 3 is 4. We have y to the third. Okay, see, that's kind of nice now. And now we can apply the 4 outside the parentheses to everything inside the parentheses. We can do x to the fourth to the fourth and y to the third to the fourth. So when we get that, we're going to get x to the what? 4 times 4. I'll kind of show that here. And y to the 3 times 4, which is going to equal x to the 16th, 4 times 4, and y to the 12th. Okay. What I want to write here is that simplify first, okay? Simplify first. It's usually pow, okay? Simplify first in this one, okay? All right, why don't you guys go ahead and try number 3, see how you do. All right, number 3. So this would be a good example where I would do pow first because inside the parentheses, there's no bases that we can really combine. So I'm just going to do, these are all to the first power here. I'm going to do the 3 to everything inside of here, okay? If you want to give that a try, now that you kind of know the first step, give it a try. So we have 2 to the 1 times 3. We have b. When there's no exponent, it's going to be to the first power, 1 times 3. And a to the 4 times 3. And also we have times b to the fourth over here, okay? So 2 to the 1 times 3 is 2 to the third. 1 times 3 is going to be b to the third. We got a to the 4 times 3 is 12. Times b to the fourth. Okay, last thing we need to do, 2 to the third is going to be 2 times 2 is 8. And then we have, over here, we have b to the third, b to the fourth. It's going to be b to the, well, I'm going to do a to the 12th first. A to the 12th. I like to go alphabetical. And then, And then b to the 7th, 3 plus 4. And that's our answer. Awesome. Ooh. And these are really hard problems here, guys. There's a lot of moving parts, so give yourself a break. We'll do some more examples here, okay? All right, negative exponents. Very cool. So why don't you guys give these a try, see if you can figure out the rule. The rules are down here, see if you can fill out what goes in the blanks. Give them a try. All right, so with negative exponents, we're going to kind of, if they're negative, they're going to be, in the numerator, it's going to go to the denominator and vice versa, right? So let's fill that down here. If we have a negative exponent in the numerator, we're going to move it to the denominator and make it positive. Make it what? Positive. And vice versa, if it's in the denominator, we're going to move it to the numerator, to the what? And make it positive still, okay? So now we know the rule. If you didn't know what that was, why don't you guys see if you can figure out 1 through 4, and we'll go through them. All right, sounds good. So here's what we're going to do. We have 2 to the negative fifth, put it over 1, and we're going to move any negative exponent's going to flip to the bottom or top, wherever it is. We have, this is going to move to the bottom. But if there's nothing left on top, we're going to do 1 over 2 to the power, 2 to the positive fifth, and 2 to the fifth is going to be 32. We get 1 over 32. All right, there we go. So number 2, we have 4 negative third. Negative exponents flip and become positive. So now we have 4 to the positive third over 1. And that's going to equal 4 to the third is going to be 64. 4 times 4 times 4. Now 4 times 3, okay? Why don't you guys try 3 and 4 if you haven't done those yet? All right, negative exponent, flip it to the bottom. It's in the top, so we got 1 over x to the 7th. And that's it. Can't do anything else with that. And number 4, it's in the denominator, so we move to the top. So we get y to the 6th over 1, which just equals y to the 6th. All right, there we go. Why don't you guys try 1 through 4 down at the bottom here? It's just like these other ones. Now we got some more practice. Make sure with numbers that you simplify them and write them as single numbers. All right, this one down here, we have 5 negative 2, put over 1, move to the bottom. We got 1 over 5 squared, and 1 over 5 squared is going to be 25. So we get 1 over 25. All right, number 2, it's in the denominator, move to the top. So we have 7 to the positive 3 over 1. That's going to equal 7 to the third. 7 times 7 times 7 is 343. There we go. Number 3 in the numerator, move it to the denominator. 8 to the 8th goes to the bottom. So we got 1 over 8 to the 8th. That's it. Okay. And the last one, we have r negative 4th in the denominator. It's going to move to the numerator. So we get r to the 4th over 1, which just equals r to the 4th. All right, there we go. Okay, one more property here, and then we'll do some more mixed practice, which are going to be a lot of stuff here, okay? So we're dividing powers with the same base, okay? See if you can figure out the rule down here for this part. See if you can figure it out. So when we multiply exponents, we add the exponents. What do you think we do when we divide exponents? We're going to subtract the exponents, okay? So now that we know that, why don't you guys, if you didn't know that, why don't you guys try 1 through 3, see how you do. All right, so what I like to do is I don't like to actually so with multiplication we did, so x to the second times x to the third equals x to the 2 plus 3, right? For this one, I don't want to do 5 minus 2. I don't want to do x to the 5th minus 2. I want to just cancel stuff, and I'm going to show you kind of how I do this, okay? So I just want to cancel the smaller number. I always want to take the smaller number and subtract it from the bigger number. So which number is bigger, 5 or 2? So I'm going to cancel out 2 x's, and if I take away 2 x's from 5, how many are left? 3. We get x to the third. That's going to be our answer. So I just kind of subtract whatever's left over, okay? And then if you cancel everything, there's a 1 down here. So x to the third is going to be our answer, okay? Now this one, the reason why I do that is because if you do c to the 5 minus 8, right, for this one, what's 5 minus 8? Well, it's a negative third, and then I have to move it to the denominator and stuff. So if I just cancel stuff where it is, it kind of saves a step here, okay? So which number is smaller, 5 or 8? So I'm going to cancel 5 c's, and I take away 5 c's from 8, I get 3. And then I just get 1 over c to the third. And see, if I did this way, I'd still have to move to the denominator, and this way it kind of keeps it in place for me, okay? Last one, we have d to the third over d to the 11th. They're the same on top and bottom, so we're going to cancel, which one's smaller, 3 or 11? Cancel 3 d's, and if we take away 3 from 11, we get 8. Our answer is going to be 1 over d to the 8. All right, and there we go. Why don't you guys try 1 through 3 down here, just like the ones we just did. Give them a try. Okay, number 1 here, we got, so which one's smaller, 9 or 14? 9 is smaller, cancel it out. Take away 9 g's from 14, we get 5 left. We get g to the 5th. All right, number 2, we have h to the 6th, h to the 15th. How many are we going to cancel here? We're going to cancel 6. We're going to take away 6 from 15. We get 9. 1 over h to the 9th. There we go. Number 3. Now we got kind of multiple things happening here, but it's the same process, okay? So how many f's are we going to cancel? Cancel 7. Take away 7 from 10, we get 3. Cancel 3 g's. We have 5 left in the bottom here. So now our answer is going to be f to the 3rd over g to the 5th. All right. Sounds good. All right, why don't you guys go ahead and try, let's try one of these together, and let's challenge yourself and try 1 or 2, give them a try. I think we're going to do number 2 first, because it's kind of a lot here. So feel free to do that, and then we'll go through them. All right, number 2. So, is there any pow happening here? No. Is there anything we can multiply straight across? Yep, we have like bases. We have 2 and 4. What's 2 times 4 going to be? We got 8. How many m's do we have here? I see 4 here and 2 here. So 4 plus 2 is going to be m to the 6. How many n's do we have? I see negative 1 here and positive 1 right here. What's negative 1 plus 1 going to be? It's going to be n to the 0, okay? I think that's it for the top. On the bottom, we just had the 4, right? So 4 kind of stays. And there's no other like bases that like m's or n's are all kind of different here. Okay, so now we have 4m to the 3rd, n to the negative 4th. All right. Okay, so we multiplied across. Are there any 0 or negative exponents? There are. We have negative exponents. What do we do with that? We're going to move it to the top. If it's in the bottom, it's going to move to the top. So now we have 8m to the 6th. Do we need n to the 0 anymore? No, it's equal to 1. I'm just going to put a 1 through it, okay? So n to the 4th is going to be up here. And then the rest is going to stay where it is. Don't move everything. You only move the stuff that's directly touching the negative exponent, okay? So keep the rest of it the same. So I got 4m to the 3rd down here. All right, so that's negative 0 exponents. Now we're going to do some canceling, okay? So if we reduce the 8 and 4 at all, yep, 4 goes into 4 once, 4 goes into 8 twice. How many m's can we cancel? There's top and bottom here. Cancel 3, leave 3 left on top. So we have 2, m to the 3rd, n to the 4th. You can put over 1, everything canceled down here if you want to, or just put your final answer, which is that. All right, why don't you guys go ahead and try number 1. We went through a hard example here. These are the hardest things you're going to see for this section, but it's just good to, it's a lot of moving parts here. Do the best you can. All right, number 1. So we have any pow happening here? No, we do not have any parentheses like outside of this. So do we have anything we can multiply straight across? We do. We got like bases. We have 4 and 2 is going to be 8. We have negative 2 u's here. We have 1 u here. So we have u to the, what's negative 2 plus 1? It's going to be negative 1. And then we have v to the 3rd by itself. Keep the v to the 3rd. Over. Anything on the bottom? Not really. So we got u to the negative 2nd. V to the negative 4th. All right, so we multiply straight across. Are there any negative or 0 exponents? Yeah, we're going to move all of them. So these are both going to move here. Both of these are going to move. This is going to move to the top, okay? But positive exponents are going to stay where they are, okay? So we have 8. So u squared is going to be on top now. We have v to the 3rd. This one's going to stay. We're also going to have this v to the negative 4th. It's going to become positive v to the 4th. Over. And then the bottom is going to be u to the 1st power, which was from the top. This was up here, okay? All right. Any other negative or 0 exponents? No. Can we do any canceling here? We can cancel 1u and take away 1 from 2. We get 1u here. So our answer is going to be 8u. And we have v to the what? We have 3 here, 4 here. It's going to be 7 total. So we get 8u, v to the 7th. And that's our answer. All right. Now we're putting it all together here. We have some really pretty complicated stuff here, okay? So I want you guys to just do as best you can. So remember, do pow first. Multiply across, negative 0 exponents, and then reduce and cancel. Let's try a couple here. We'll try one together here. Actually, let's do No, you know what? Try them on your own. I want to see how you do here. I don't want to spoil the surprise here. So give it a try. Let's go through when you're done. All right, number 1. So do we have any pow pow here? We do. I might do this pow pow. So we have a pow pow. Let me use it for color here, actually. See how we have this pow pow inside of here? I might do that first, but I also might, on the top here, I might combine some like bases, like V and V there, to kind of clean things up a little bit and make things a little bit nicer. So we're going to keep the outside one the way it is. So on the top, we're going to have 2 u to the third. And then what do we have for v's? We got v to the first here, v to the negative second, so we're going to v to the negative 1. Okay? Over, then we're going to apply this 3 to everything in the parentheses here. These are all to the first power. We're going to apply the 3 to everything in there. So we have 2 to the 1 times 3 is 2 to the third. Then we have u to the third, 1 times 3. We have v to the 0 still because it's 0 times 3. And we keep the 4 out here, okay? All right. So yeah, now we could do some canceling here. I might actually do pow pow now. I think I don't like to put off pow pow too much. I'd probably do that right now because they're all kind of combined. And I just 2 to the third here, I would kind of keep the way it is until we kind of simplify this 4th power. So I'm going to do the 4 to everything in the parentheses, literally top and bottom, okay? So we have 2 to the 1 times 4 is 2 to the 4th. U to the 3 times 4 is 12. V to the negative 1 times 4 is negative 4. Okay. Good. Over, on the bottom, we have 2 to the 3 times 4 is 2 to the 12th. U to the 3 times 4 is 12. And V 0 times 4 again is going to be 0. Okay? All right. Do we have any negative or 0 exponents here? We do. We're going to move this negative 1 to the bottom. This is going to become a 1. Okay? It's kind of gone. So now what we have, you know what I wouldn't do here is I would not do 2 to the 12th on your calculator. What I might do now is I might do some cancellation like before I do this here. So how many 2's are going to cancel here? I'm going to cancel 4 2's, and we take away 4 from 12, we get 8. So now what I get, I'm going to go this way this time, okay? I'm going to have, and how many u's are going to cancel? We have 12 on top and bottom. So actually, they're all going to cancel, so they kind of go away. So this is gone. So on the top, we're going to have 1 over, we have 2 to the 8th, and then we just have v to the 4th, right? Because this v to the 4th went to the bottom. And what's 2 to the 8th going to be in your calculator? It's 256. We have v to the 4th. And that's your answer. So this whole big thing kind of reduced to that. Okay, and I would encourage you on your quiz and stuff, just keep going. Don't panic. Just keep showing the way you know what to do for each step, because people give up right here and then they lose a lot of points. Okay, so it is a lot. There's a lot of things that could go wrong. I've made mistakes when I'm making a key for stuff too, so even I make mistakes. So just keep going. Okay. All right. If you want to try 3 and 4, now we went through, or sorry, 2 and 3. Now we went through 1. Give them a try. All right, number 2. So any pow pow here? Actually, there is, but I'm actually gonna. This is kind of a trick question here. What's the exponent on the pow pow? It's 0. So it's actually, this whole thing just becomes what? Anything to 0 power is just 1. So we have 1 over, and we have x squared times x squared is going to be x to the 2 plus 2 is 4. So if you did the 0 power there, I'm sorry if I made your life miserable, but apologies. That's kind of a trick question there, because sometimes people will throw in 0 exponents, okay? And number 3, if you try to do that one too, I'm also very sorry, because what's it to the power of? It's power of 0, so the whole answer should just be what? Should just be 1. So you did that whole thing for no reason, so I apologize. Yeah, and then we have space for extra practice, but that should be it for today. Thank you for watching. Have a great day, and we will talk soon.